and welcome to the show floor at IPC Expo 2024. I am Eric Miskell with EMSNOW. I'm here in the Indium booth with Chris, Senior Product Manager for Indium. Good to see you.
Good to see you.
Yeah. We're on the last day of the show. How's the activity been so far?
I think it's been spotty, but it's been a pretty good show. I think there's been a lot of customers coming by talking about solder, talking about reliability, talking about sustainability.
And that's what I want to talk about. Let's get right in on the sustainability and kind of the sustainable practices for modern manufacturing, obviously becoming more important.
Yeah, especially in the automotive realm, we're seeing a lot of discussions happening. We're seeing a lot of new growth in the sustainability departments. These departments are becoming massive, and everyone's talking about how can we be a more sustainable industry? How can we be a more sustainable society? So it's a super important topic that we're all talking about, and I think Indium's got a lot of value for the customers that do have the interest here.
Yeah, and specifically, is that the Durafuse?
It is, yeah. So there's a lot to sustainability, whether it's upstream or downstream sustainability. But what I'm focused on more is what can Indium Corporation do for our customers to become more sustainable. And the Durafuse LT is one way that we can do so. By reducing the reflow temperatures of the oven, we're able to save on energy consumption. So that means we're saving on cost. It means we're saving on energy, which equates to both CO2 emissions and cost.
And your customers, obviously, they're tracking that more and reporting on that more out of the factories nowadays.
100%. Yeah, everyone's tracking it, everyone's calculating it. And the Durafuse LT, by going down to 200 to 210 degrees C, we're able to save about 10 to 15% on electricity consumption. That's equaling huge savings in carbon emissions, huge savings on energy cost, which is extremely important in the European market where energy costs have skyrocketed because of the war. It's extremely important into the OEMs in especially the Silicon Valley area where they're really concerned with carbon footprint and eco-friendliness. So China is also, and Southeast Asia for that matter, is also looking at this and saying, yeah, we want to reduce our energy consumption as well, and become a more sustainable world.
But take me back, though, when the Durafuse originally developed, was it with this in mind, or was this just kind of a happy offshoot of it?
It wasn't really the original intention of the Durafuse LT technology. The original intention was drop shock performance, low temperature, and being able to provide a high reliability, low temperature alloy. Since then, we've branched out with our value propositions for Durafuse LT. We have thermal cycling reliability that we've found is, in some cases with wafer level CSPs in the mobile type space, we're able to outperform SAC 305 with thermal cycling reliability. In fact, the drop shock reliability, if you employ the right processing, you're able to improve the drop shock performance compared to SAC 305 as well. Large BGAs in the server market, where you're seeing greater than 50 millimeter packages. I've seen 120 millimeter square packages. So huge BGAs with very complex warpage profiles. But the real trick with Durafuse LT is you can reflow it at 220 degrees C, and at 220 degrees C, the component is flat. So you're able to make those connections. But if you go any higher than 220 degrees C, you start to get M-shape or W-shape warpage profiles, and it becomes very complex with a lot of defects involved. So there's a lot of value propositions around the Durafuse LT, and the sustainability message is really coming out of that technology. Now, a lot of people say that, sure, you can get 10 to 15% reduction in energy by using the Durafuse LT at 200 to 210 degrees C. But bismuth-based alloys, you can even get more energy savings. And that's true.
So you can do it at a lower temperature.
You can do it at a lower temperature. You can reflow at about 170 to 190 with the bismuth alloys. But the The problem with that is the bismuth alloys are brittle by nature and the reliability isn't there. So Durafuse LT is able to reduce your energy consumption but still maintain the reliability of SAC 305.
You say it isn't there. Isn't there yet, or is that just a natural condition with the bismuth?
Yeah, I think it's going to be a natural condition with the bismuth. I don't think anyone's really going to come up with a reliable bismuth alloy, at least a high bismuth in the 30 to 50% range. So it's just the nature of the beast.
Yeah.
There are certain applications that can still utilize the bismuth alloys, right? The stuff that's going to stay put, that you don't have drop shock or mechanical reliability concerns. But those are fewer and far between. You know, people are really looking at reliability on all levels now in all industries.
So is the Durafuse LT, is that applicable to the whole spectrum of different products, or is it unique to certain sectors?
No, in fact, we have applications in the automotive space. We have applications in the mobile space. We have applications in the server space for the Durafuse LT. It spans the entire industry. There's an application need for every single market space out there.
So having dealt with some floor managers before in my career, I know that they've become very set in their ways. How was it getting them to change those oven temperatures? Was there a bit of an adjustment period there?
No, it's actually a pretty simple changeover. You know, you just change your oven temperatures.
They didn't need convincing. It was just
the hardest part is all the reliability testing that a lot of people are going to do. They're going to do thermal cycling reliability. They're going to do drop shock reliability testing. Any alloy change is going to have that reliability question, right? Yeah. Is this going to affect the reliability? But when people do switch to the Durafuse LT, they're usually pretty surprised at the results. Wow, I can really reflow this and still maintain the reliability of my solder joints.
The other thing I wanted to ask about is I know there's some kind of eco-friendly packaging that you've developed as well for this. Tell us about that.
Sure. So we're going to start to implement cornstarch coolers instead of EPS coolers or styrofoam coolers for all of our shipments in North America, and we're hoping to expand that on a global level at some point in the near future. We're looking at post-consumer recycled plastics for our solder jars or cartridges. We're looking at using honeycomb craft paper instead of bubble wrap to become more sustainable. And I think Europe is really pushing us in that direction with the plastic taxes and stuff that are happening in Europe. But it's us. It's our culture at Indium Corporation and our sustainability messages and programs that we put in place over the years. They're really driving us for a better world.
Yeah, and that's just sharing the best practices from one and globalizing it, so to speak. In this case.
Yes.
Yeah. Before I let you go, let me ask, on the last day of the show here today, is there any kind of insight or learnings that you're taking away from your couple days on the show floor interacting with customers?
I think the industry is still growing. I think there's a lot of new, exciting technology out there. And I think that's the most exciting part about our industry is it's always changing. It's never the same thing. I wake up every day with a new problem that I love the engineering. So Indium Corporation's been big on from one engineer to another for years and years. That is our motto. We love having those conversations with other engineers to try to fix problems.
Yeah. That's good to hear. That's great insight. Chris, thanks for the time. I wish you continued success this year. Hopefully we catch up again sometime.
Okay, thank you very much.
Chris, thank you.